It can be both visible and invisible. It can be short and long. It is a piece of information and radiation at the same time. It can be dangerous, but it does not have to be. It is not the most interesting man in the world. It is electromagnetic radiation, a kind of energy known as light. But visible light, the stuff you see, is only one form of electromagnetic radiation. There's also gamma rays, X-rays, ultraviolet light, infrared, microwaves, and radio waves. We'll explore some of the important concepts related to light in this lesson. Let's begin this lesson by discussing some important concepts related to light. As per the intro, light technically refers to all forms of electromagnetic radiation. However, do keep in mind that the word light is often used colloquially to refer to the electromagnetic radiation we can see with our eyes, that is to say, visible light. Other than visible light, all other forms of electromagnetic radiation are invisible to the unaided human eye. Also, when I say radiation, as in electromagnetic radiation, I don't want to freak you out or anything. In the context of this lesson, radiation refers to something radiating out or spreading outwards from a certain point. This is what light does. That's why it's a form of radiation. Sure, X-rays can be dangerous in high quantities, but visible light, not so much. In any case, both are forms of radiation, and they are electromagnetic because the energy is conveyed in the form of changing electric and magnetic fields. This electromagnetic radiation spreads out through space at a set speed. That speed, the speed of light, symbolized by a lowercase c, is 300 million meters per second. All forms of electromagnetic radiation travel at this speed. At such a speed, electromagnetic radiation can circle the equator 7.5 times in 1 second. Electromagnetic radiation has two key properties. It has wave-like and particle-like properties. When you see a rainbow, you see visible light behaving as a wave that carries energy. Like visible light, all forms of electromagnetic radiation have something known as a wavelength, the distance between two successive peaks of a wave. It's typically represented by the letter lambda and measured in meters. If you're unsure of what I mean by wavelength, imagine throwing a rock into a pond and watching the ripples spread across the water. If you could pause such a scene and use a ruler to measure the distance between the peaks of the wave, that would be a wavelength. Wavelength is inversely related to the frequency of a wave, the number of cycles of a wave that passes a specific point in 1 second. It is usually represented by the letter nu and measured in cycles per second, or hertz. The higher the frequency of a wave, the shorter the wavelength, and vice versa. In addition to behaving like a wave, electromagnetic radiation can also behave like particles. This is the property of light that cameras depend on to take a picture. A particle of electromagnetic radiation, sort of like a small packet of waves, is known as a photon and sometimes called a light quantum. Photons carry energy, and the amount of energy a photon carries is directly proportional to its frequency and inversely proportional to its wavelength. This means high-frequency, short-wavelength electromagnetic radiation like gamma-ray photons carry more energy than the longer wavelength, lower-frequency photons of visible light. This is why higher frequency UV rays can give you a tan and cause skin cancer. But a heat lamp utilizing lower energy infrared light can't even give you a tan to begin with. However, if you were to confine a lot of low energy photons into a small space, like in a microwave, you can indeed transfer a lot of energy even when using such low energy photons, the microwaves. To end this lesson, I'd like to say a couple of other important things regarding light, meaning all of electromagnetic radiation. Images like that on your screen like to divide the different forms of electromagnetic radiation into wavelengths with definite boundaries. But in nature, there are no such divisions. Such divisions are performed solely for human purposes. This means that there is no actual distinction between something like the longest wavelength X-rays and the shortest wavelengths of UV light. Finally, light carries information about the objects emitting it. Other lessons explain how so in more detail, but suffice it to say that light can be used to determine characteristics of celestial objects, like their temperatures and chemical composition. Electromagnetic radiation is known as light. There are different forms of electromagnetic radiation, including gamma rays, X-rays, ultraviolet light, visible light, infrared, microwaves, and radio waves. The speed of light, symbolized by a lowercase c, is 300 million meters per second, and thus all forms of electromagnetic radiation travel at this speed. This electromagnetic radiation has two key properties. It has wave-like and particle-like properties. A wavelength is the distance between two successive peaks of a wave. The wavelength is inversely related to the frequency of a wave, the number of cycles of a wave that pass a specific point in 1 second. Electromagnetic radiation can also behave like particles. A particle of electromagnetic radiation is known as a photon, and sometimes called a light quantum. Photons carry energy, and the amount of energy a photon carries is directly proportional to its frequency and inversely proportional to its wavelength.